So today we're going to talk about balanced versus unbalanced forces, and I'm going to give you some examples of both. But before we do, I want to kind of give you a definition of a balanced force and then an unbalanced force. So a balanced force is something that has no motion or it shows constant speed. So if I have a car traveling at a constant rate of speed, it would be considered a balanced force. Okay, unbalanced is going to show motion or changing speed. Okay, so anytime I have a motion that is not constant and I have a speed that is changing, I'm going to have an unbalanced force. So let's look at some examples. Cards balancing on each other. So if I take two cards and I balance them and there's no motion involved, that's going to be considered a balanced force. Pushing a box with equal and opposite force. So if I take a box and I push on one side and then I push on the other side with equal and opposite force, I am going to have no motion, and so therefore I have a balanced force. Unbalanced examples might be a person being pushed in a rolling chair. So when I push the rolling chair is going to move with changing speed, and so it is going to be unbalanced. A man in a parachute, I have two forces. Air resistance is going to be one, gravity is going to be the other, but I am going to have a changing speed involved in that, and so it is considered an unbalanced force. An arm wrestling stalemate. So a stalemate means nobody is winning, and so there's no motion involved, and so that would be balanced. Pushing a skateboard. So when I push a skateboard, I have the push. Okay, so that's one force, and the opposing force is going to be friction. Working against the skateboard, I am going to have a changing speed, so it is an unbalanced force. A person standing on the ground. The floor is pushing up on the person, gravity is pulling down on the person. However, those two cancel each other out, they're equal and opposite. So we have a balanced force with no motion. And so I've got a couple of questions, and I've got the answers already up there for you, but it's important to realize that we always have forces working against things. So for example, if I push a skateboard, the skateboard eventually is going to stop rolling because friction and gravity are working against the skateboard, and eventually friction and gravity will win out, and that's what's going to cause it to stop. And when a box is pushed, why does it move? Because the force of my push is greater than friction. If the force of my push is not greater than friction, the box is not going to move. Okay, so we always want to consider friction and gravity when we're looking at objects in motion. Okay, so now how to solve or calculate forces, net forces. Okay, so in this first example, I have 5 newtons, and newtons is just the unit of measurement for force. So I have 5 newtons of force going to the right, and I have 7 newtons of force going to the left. And so I'm just going to subtract these, so I get 7 minus 5 equals 2. So I have a net force of 2, but I'm going to go in the direction where the greater force is, and because 7 is the greater force, my net force is going to be 2 newtons to the left. Okay, so in this next example, I have 5 newtons to the right and 7 newtons to the right, so now they're working together, and so we're going to add these two numbers. So 7 plus 5 equals 12. And since both of them are headed to the right, my net force would be 12 newtons to the right. And then in this last example, they're working against each other again. They're just pulling away from each other. And so I'm going to subtract. So 7 minus 5 equals 2. So 2 newtons. But I'm going to look at the greater force to see the direction. And so the direction is going to the right. So my net force is 2 newtons to the right. So you'll notice in all of my net forces, I have a couple of things that are really important. First of all, I have the number, the difference, or the sum of the net forces. and then I have newtons, which is the unit of measurement, and then I have the direction that it's going to travel. To have a net force, I need to have all three of those things to know truly the net force of motion. Okay? Okay, so let's look at this different type of problem. So in this problem, I have a ball, and this ball has two forces working on it. I've got one force that's working to the north and one force that is pushing to the west. And so the forces here, they're not assigned a number. So let's just assign 10 newtons of force to the north and 10 newtons of force to the west. So are they equal? Yes. Are they opposite? No. Will this move? Yes, it's going to move because they're working together. And it's going to move in this direction. So it's going to go diagonal. So we would say that is northwest. And this is not considered a balanced force because I do have a motion involved. Okay, so let's look at one more example. Same thing. We can use the same numbers. We can use different numbers. It's the same type of problem. So let's say I have 20 newtons of force here and 20 newtons of force here. It is equal, but it's not opposite. And so this is going to move, and remember it's going to go in a diagonal direction, so it will go southeast. And we do not have a balanced force because we do not have equal and opposite. So for it to be considered a balanced force, it does need to be equal forces, and it also needs to be opposite forces. Okay, so now you're going to go into Schoology and you're going to have some practice problems that you are going to work through. Your practice problems will follow exactly the same process that I just showed you. So if you need to rewatch this video, please do so. If you have questions, please let me know.